Good afternoon. Good afternoon to all of you. First and foremost, I would like to thank Unkwaji Center for Development Studies for giving me the opportunity to conduct this workshop. Okay, let me introduce myself first. I'm Dr.Rulia Akhtar, Research Fellow at Unkwaji Center for Development Studies, University Malaya. So, dear participants, do you hear me clearly?
Yes, doctor, we can hear you. Good afternoon, doctor.
Okay, thank you. So without further delay, let's begin our workshop. Okay, today actually I'm going to talk about autoregressive distributed lag model or ARDL model. Basically, this workshop I will separate into two parts. This workshop, actually first part, I'll try to explain the basic concept of ARDL model, how this ARDL model looks like, what are the advantages of ARDL model, and so on. And second part, actually, that one is more important for us. That one is the practical part. I will show you step by step. First beginning at the beginning from how do we import the data from Excel file to EViews and until the last. So now I don't know, I have here some problem with sharing. Just wait for a few seconds. Huh? Okay, so same problem, Fadli. Why the technical problem? You can see this transcript recording on. Okay. Anticipated as about closing captioning. Sharing. Sorry, we have some technical problem. Just wait for a few minutes. Huh? What's the now? So do you hear me, the participants?
Yes, doctor.
Okay, thank you. Okay, so first part actually the basic concept of ARDL model I have already mentioned, and we will try to see the different types of lag and advantage of ARDL model, or why should we use the ARDL model, not any other model, and how do we select the model? Actually, the model selection criteria, and after that I will show you the estimate procedure. Actually, this one I will show you the graph in the graph form, but in second session, actually, I will do the practical part. And last but not least, I will show you one of my published article that this one is recently published in the Economic and Restructuring Journal. Okay, and the second part, I will show you the introduction to data analysis uh, using EViews software, and how do we export data from Excel to EViews. And after that, this is actually the practical part. So I just mentioned here, if you have the experience, so you can see in a paper or in your thesis, you can write everything, right? The descriptive statistics, correlation matrix, and after that, we need to test the stationarity test, and then like selection, how do we select the leg, and the bound test approach, ARDL method, and after that, diagnostic test, causality test, and finally, robustness checks. And we will show you how to write the result of ARDL analysis. So I cannot actually give you the full slide. Once I give you the slideshow, that one actually doesn't work sometimes. Okay, now uh, here, now let's understand the basic ARDL model. What is the ARDL model actually? ARDL model is the econometric modeling framework, that is the relationship. We need to find out the relationship between two or more time series variables. Particularly, it is useful when the non-stationary time series data, and it's used in dynamic modeling. Now, if we talk about any other econometrics modeling, it is very important assumption that the model or econometric model or economic model, that is need to be the correct functional form. So what is the correct functional form? Okay, correct functional form is that we need the most appropriate variables, and this variable should be in the most suitable format. So whatever we include the variables, we think a paper, or we think a title of, or we can take a appropriate topic, but we need to make sure we have the appropriate variables also. Without that, actually this is not good for our analysis. Okay. When we talk about the correct functional form, one of the most important consideration is that the time series data, we need the model dynamics. You see, the dynamics model and with the appropriate lag structure. Now, what is the dynamics model? Dynamic models is that we need to add the lag variables in the right hand side. You know the equation, right? You know the equation we have two sides. One is dependent variable side, one is independent variable side, meaning that one is left side, one is right hand side. But we need to include the lag variables or lag values in the right hand side. This is actually the dynamic models. So a dynamic model, and when we talk about the dynamic models and lag structures, so there is the any problem of the functional form is the lack of lag structures in the model. Now, what is the lack of lag structure in the model? Meaning that when we fail to add the lag variables in our model, we have some problem. What is that problem? This is actually the autocorrelation or serial correlation problem. So this is actually a issue because once we have the serial correlation problem or autocorrelation problem, we cannot take this model, or we cannot, this model is not fit for our analysis. So here, how do you overcome this autocorrelation problem? So we need to add lag variables, lag dependent variables to the model itself. So here, meaning that we have dependent variables and independent variables. So we need to add another variables as the dependent variable itself can be the independent variables. This is the lag structure, to remove the autocorrelation or to overcome the autoregression problems. So, sorry, meaning that if the lag variables can produce a better functional form, but when we add or we need to add the variables, we need the strong justification. Why do you add? So how? This is either theoretical reasons or in the previous research. Based on the previous research, we need the strong justification. Without justification, because sometimes some papers they ask, why, what's the justification of your adding this one? So we need to the strong justification. Now let's look at the different types of lag. There are three types of lag. One is autoregressive lag, one is distributed lag, and another one is moving average lag. So autoregressive lag refers to dependent variables, and distributed lag refers to independent variables, and moving average lag refers to error term. So in this workshop, we will focus only these two types of lag. Why? Because our model is autoregressive distributed lag model. That's why we will focus only these two types of lag. Okay, now let's look at this. Before existing the Airedale model, which model actually that time was commonly used? So the before existing the Airedale model, to analyze the relationship between the different variables, vector autoregressive model and vector error correction model have been common test. And that time, this one actually, we assume that all the variables are stationary at the same order of integration. What is that meaning? The same order of integration, meaning that the variables should be stationary at level or stationary at first difference. Sorry, this one should be 1. Okay. So, but if you have, suppose you have 10 variables. So all the variables cannot be the same order. It's very difficult to get all the variables in the same order. So that's why the ARDL model, formulation of ARDL model. Now, who developed the ARDL model? Actually, Pesaran and Sin, 1995, they develop the AirDL model. Why? Because AirDL model we can use, no need all the variables are same order of integration. We can use mixture of the both, either I0 or I1 or combination of both. So this is the flexibility. So that's why we use the AirDL model. Now let's look at the AirDL equation, actually how these equations looks like. Okay, so I didn't put it here, the normal econometric model. So that one actually is supposed to be y equal to, supposed to beta 0 plus beta 1 x plus root of. Okay, this is actually the equation, normal equation. Okay, so here, as you can see here, this is our dependent variables. Dependent variables is the time value of t. Okay, so here I can say here, there are three types of data, I think. So one is cross-sectional data, one is time series data, and one is panel data. So our focus only the time series data. So time series data, so here we put it here T for time trend. So you see here, what is the dependent variable? This is a function, this is the constant term, and you see here, this is our independent variable, is the current period and the lag period, 1 period lag. We put it here. This is actually the this until Q, because this is our independent variable, this one. And do you remember that things autoregressive is for dependent variable and distributed for independent variables until Q. So as I mentioned before, we need to add the lag variables, lag dependent variables. You see this one lag dependent variable now itself is a independent variable. So here, 1 period lag, we add 1 period lag until lag P. P is for the autoregressive lag, right? So you see here, arrow term, we didn't put it here any lag because our model is autoregressive distributed lag. So we ignore these things here. So now this is the actually the difference for change of YT and this until this, okay. Okay, this is actually short run equation and this is the long run equation. So here and in the AirDL model, actually it is very critical for selection the lag criteria. So how do we select the optimal lag? There is different types of selection criteria. So commonly we can use the Ekaika information criteria or SWOS information criteria. So in this model or in this workshop, we will use Ekaika information criteria. So lowest the value, better the model. Now let's look at this one actually long run relationship. So one we test this long run relationship, so we need to check either there is a long run relationship or not. So we can see that one is the bound test. Okay, we need to test the bound test or F test. So how? You see that Hayes not is the null hypothesis. Hayes not meaning that no. So here lambda 1 equal to lambda 2 equal to 0, meaning that there is no conjugation relationship or there is no long run relationship between the variables. And alternative is not equal to 0, meaning that there is a long run relationship exists. So how do we test this one? You see, we see here that we can test from here the boundaries. Excuse me. Sorry. Okay, so here, uh, if the F statistics value, meaning that our calculated F test, the bound test value is greater than the upper bound critical value, then we can reject the null hypothesis. So if we reject the null hypothesis, meaning that we accept the alternative hypothesis, am I right? Okay, so we can say that there is a long run relationship exists. So here you see here again, if F statistics is greater than the upper bound critical value, meaning that reject the null hypothesis, so there is no long run relationship. So we can take this one, right? The existence of long run relationship. So here, three things you must remember. If F statistics is lower than critical value, meaning that there is no long run relationship. So if there is no long run relationship, so we cannot use the ERDL model. So we can use another model. And if the F statistics value is in between, meaning that the not lower than a critical value and not upper than in between. So the result is inconclusive. We cannot conclude anything. Okay, now we can see the error correction term or ACT model. So here, this is for the ARDL model. This is actually very, very important things. And this is ECT. Okay, you see here, same as before, I just change the long run with the error correction term. ECT, 1 period lag value. So here, once we will test this one, so the lambda sign should be negative. You just remember this thing. This is should be negative and significance. If this value is negative and significance, meaning that there is a long run relationship between the variables. And this is actually the speed of adjustment, meaning that how many percent reach to equilibrium from the short run to long run, or how many years to get back the equilibrium point. Some of the articles you see, they mention the percentage. You can see here, you can see from the analysis, but sometimes they mention the year. How do you get this year? Okay, I will show you later on. Okay, now let's look at the advantage of the ARDL model. Why should we use the ARDL model? What are the advantages of the ARDL model? What are the benefits of the ARDL model? So ARDL model, actually we can use either the small sample size. We no need to have the big sample size. Sometimes actually data availability is the problem. With this problem, so we can easily, if we have the small sample size, so easily we can use the ARDL model. And actually this is the data flexibility, meaning that here actually we can say the variable flexibility or data flexibility. So how ARDL model does not require all the variables of the model to integrate in the same order. Previously, I have mentioned, right, the vector regression model or VAR model. That time, the variables are integrated at the same order. But here, no need. The variables are integrated at the same order. And here, we can use easily I1, I0 or mix up both. So some variables are stationary at level, some variables are stationary at the first difference. So easily we can use this one. Okay, now causality analysis. Okay, these models allow the examination of causal relationship between the variables. So here, causal relationship meaning that either x cause y or y cause x or both cause both x cause y, y cause x. Or this is the causality analysis and also the dynamics models. I have already mentioned the dynamics model. So it captures the dynamic interaction among the variables over time. This is especially useful when dealing with the time series data where variables may have the left variables. In the forecasting, okay, forecasting actually important for the policymakers or decision or the planning. Okay, so ARDL models can be used to forecasting future values of dependent variables based on the historical data. Because we have the past value, we have the present value. Based on this, the policymakers or decision makers, they can forecast what happened in the future should be. So this is important for ARDL model. And the co-integration analysis, the ARDL models are applicable when dealing with non-stationary time series data. It helps identify the co-integration relationship that actually imply a long-term equilibrium relationship between the variables. Interpretability, next one. Okay, so here, interpretation, actually the important. How do we interpret our result, right? So, ARDL models coefficients have meaningful interpretations, okay, which aids in the understanding how change in the independent variables actually, how much change when independent variable change. So what are the effects of the dependent variables? So how we can interpret these results. And finally, model comparison. This is also important assumption or important benefits for the ARDL model because researchers can compare different types of ARDL model. Specification how? Because different types of lag, we add different types of lag or we include more variables or we exclude some variables, then we can compare which model is better. So we can compare some of this model. So better model we can take for our analysis or our research. Okay, now let's look at this one. Then this one actually is how do we select the model? Which model suit for our estimation or our analysis or our research or our article? So which model should we use? Okay, so first we need to test the unit test, meaning that stationary test. We should use this stationary test first. So here, all variables are stationary at level. So we can use the simple regression analysis. No need to ARDL, nothing. No need go here. Okay, now all variables, if the all variables are stationary purely I0, meaning that at level or I1 is first difference or combination of both. But make sure no variables are I2, meaning that no variables are second difference stationary. So if there is second difference, so meaning that you cannot use ARDL model. So then we can use ARDL model. So I put it here both non-linear ARDL model also because non-linear ARDL model actually the advanced level of ARDL model. So our today's focus only the ARDL model. So inshallah next time we will do it the NARDL model also. So I will not focus these things here. All variables are stationary at the first difference, so we can use the co-integration unrestricted var error correction model. Okay, so here this is today's not consideration this part, so we will focus on this. Okay. Okay. Now, how do we estimate the ARDL model? How do we go through? Or this is actually sometimes if you have written a thesis, you have the experience, or you are in the new, so you can know the sometimes we need to put in a figure form. This is the estimate procedure in the methodology part. We need to put this on. Sometimes we put in the articles also. So firstly, we need to do the descriptive statistics. Here, descriptive statistics, why? Because descriptive statistics, when you put it here, researchers or readers can see at a glance the figure of your article, or this is the figure out. He or she can easily understand this one. Then correlation coefficient, why? I will explain this one later because I have, I think, more slides with this. Okay, coefficient correlation. So here, is there is any relationship between the variables or not? If there is a relationship, either the variable is a relationship or a strong relationship, or there is no relationship. Now, you need to test. You need to test actually the stationarity. Sorry, yeah. Okay. Stationarity test. Before going any other analysis, we need to do the stationarity test. Any other econometrics analysis. After that, like selection criteria, should we select? So there is several types of criteria, either Akhtar information criteria, SWOT information criteria, finite prediction factors, and also Hannon criteria. So it's up to you which one you should choose. And after that, ARDL model. Okay. So here, before going to ARDL model, we need to actually ARDL. But once we test the ARDL model, we need to test the bound test. Long run relationship. There is any long run relationship or not, we need to test through the bound test. Now error correction term I have already mentioned. So error correction term we need to check. And after that, once we will do this step, after that we need to check the validation of the model. If the model is free from serial correlation or free from heteroscedasticity, or the model is the data set or the model is linearly distributed and the uh, model is stable or not, we need to check here. Okay, after that, the causality test, the causal relationship between the variables. We need to check this one. And finally, we can see the robustness of our model. Robustness, so we need to check the dynamic ordinary least square or fully modified least square or canonical regression analysis. So here, if you mention, you can use 1, 2, 3, or you can use both, or you can use 2. It's up to you. Okay. Okay. Now, I will show you the one of my paper. Actually, this is the link of this paper. If you need, I'll give to you. So this paper published in Economics and Restructuring Journal. This is ISIQ 2, and this paper is published in 2023. So you see here, the title was The Economic Growth, Gender Inequality, Trade Openness, and Female Labor Force Participation. So here, why a nonlinear ideal approach? I will show you. Because in this paper, I did linear and non-linear analysis both. So I will show you only the linear part. Non-linear part, I will not show you. So this paper is published, actually this one is good journal. We have published. Okay, so here, what is the objects of this paper? So object is, you see here, both. So to examine the symmetric and asymmetric. Symmetric is actually the linear model, ARDL model. Asymmetric is the non-linear or NARDL model. Okay, so here, to examine the symmetric and asymmetric association between economic growth, gender inequality, trade openness, and female labor force participation. Actually, so what are the effects of economic growth if this one change? So linear meaning that you can only the direction, either negative or positive. So here in this study, the data period was 1980 to 2019, 40 years of observation. This is time series data. So method I just use in this article, I have used both. So today's focus only our ARDL model. Because nonlinear model is actually the advance of ARDL model. So if you are interested, then we will do it later. So this is our variables, or what variables we used for this paper analysis. So now I will show you how many steps I did it. So actually you see, I have already mentioned we need to do the descriptive statistics. Okay, so here, descriptive statistics, some of the articles or some of the paper, research paper, you can see all of things. So, but we need only mean, maximum, minimum, standard deviation, observation. That's it, enough. But sometimes you can put all the things, meaning that there is the minimum value, skewness, hypothesis, Zerkbera, probability, sum of square, etc. So actually no need. If you want, you can get to this. Because descriptive statistics provide us the measure of central tendency, right? And measure of dispersion. And also there is the normality, theta normality. So here, if the standard deviation from the mean value, if the standard deviation is lower than the mean value, meaning that your model is performed well. So make sure you can check these things. Okay, so okay, here I didn't put the correlation matrix because sometimes actually if we consider all the application, that one is quite big, and sometimes the journal doesn't allow, they have the limit. So that's why some papers we skip this part, but we need to do it. Okay, now the stationarity test. In this paper, I did 3 tests: augmented decupolar, Lipperon, and KPSS test. So you see here why we use the ARDL model and NARDL model. You see, this variable is not stationary at the level. But after first difference, this variable is stationary. Now this one is stationary at their level, but after first difference, okay. So here, sometimes we will do it once here. If here is stationary, so second time no need to test the stationarity test because you have already this variable is stationary. You see, and some of the variables you see here, this is trade openness is stationary at level, but once we did the first difference, this variable is non-stationary. So here, so meaning that you see here, some of the variables are stationary at level and some of the variables are stationary at their first difference. So therefore, we can use the Airedale or an Airedale model. Okay, now you see here, the lag selection criteria, you have how many? 6, right? 6 criteria. Basically, majority time, you can use only these 2 types of lag. You see, I have already mentioned lowest the value, meaning that better the model. So lowest value meaning that we need to select one lag because this is the lowest value. You see, the steric marks mention the lowest value of this lag selection criteria, either Akaika or SWAS criteria. You see here, all things are mentioned here. This is actually how do you write up or how do you put in a table form in your article or in your research paper or your thesis. Okay, now, okay, you see here, once we select the leg, I will show you the polynomial graph. Why? Because you see, polynomial graph, this is actually the criteria. If all dots are inside the circle, meaning that this optimal leg 1 is appropriate for this model. Okay. Now, this is the bound test. So, you see here, I have already mentioned if F statistics is greater than the upper bound critical value. This is upper bound, this is lower bound critical value. Okay, so here 5.897. So this one is 5% significance level, right? More than 5% significance level. So 1% we cannot take because this is more than this. So here, meaning that there is a co-integration relationship. If co-integration relationship, we can proceed the next step, right? Co-integration meaning that we need to do the Airedale model, or see this is actually we need to do the error correction job. Okay, so here, okay, this is the long run analysis result. This is the short run analysis result. So here, I didn't put it here the p-value because I've already put it here. If you mention here the static marks, meaning that this is 3 static marks, meaning that this is the 1% level of significance, and 2 meaning that 5% level of significance. If 1 meaning that 10% level of significance. So here, you see here, our dependent variables, the time is economic growth. So meaning that here, we can consider here female labor force participation. Okay, so here, male. Why male labor force participation has the negative relationship of economic growth? Why? So, okay, so I think this is because sometimes they don't have the advanced skill or technological skill. So more labor force, female labor, male labor force participation, but that one actually doesn't affect the economic growth negative because of this because they are not willing to accept the technology, or they sometimes somebody is not like to learn something, so that's why this is and you see female labor force participation. If female labor force participation, uh, okay, so here the GDP or economic growth is increasing. So here, okay, so something is like that, but we cannot only say 1% increase in female labor force participation. That one leads economic growth by 3%. Or you cannot. You okay? Only say, but you need to give the strong justification why. What is the reason behind? You cannot only explain the table. You must give the support from the previous research based on the literature. So that's why this is important. The explanation actually the important support this discussion. Okay, now I move this side. You see the error correction term or ECT here. Our assumption is this is should be negative and significance. So we can fulfill our criteria. This is negative and significance, meaning that we have the long run relationship exists. So here, how many percent speed of adjustment here? 56% speed of adjustment. Okay, so here, and how many years? How do we calculate? Okay, I will calculate once we will do the practical, but that time I will show you how. Because this is the speed of adjustment, meaning that how many percent, how fast go to the short term to long term. So go to the equilibrium point. How fast is it? Okay, this is error correction term, actually the speed of adjustments. Okay, so here, okay, normality test we have here already mentioned. Where our test? Okay, so this is real correlation test. We did all the things here. Okay, and Darwin-Watson value actually all times, majority times almost 2. Is if almost 2, meaning that okay, but if less than 1 something like that, or uh, close to 2, okay. But if this value is lower, meaning that there is a spurious result, so you cannot use that something is there wrong, or some things there is a problem. Okay, now this is the stability of the model. How do we check this stability? You see here, we can check cosine and cosine square of the test. So if this blue line, so within this 2 red dotted line, meaning that our model is stable. So this is actually the criteria. If the blue line is between the 2 dotted red lines, so meaning that this is actually 5% significance level. So meaning that our model is stable. If not, then something is wrong there. We cannot take the model. Okay, sorry. Huh? Okay, so here again some problem. Okay. So here after that the causality test. causality test actually, either there is, I have already mentioned, either there is a one-way relationship or two-way relationship between the variables. You see here, economic growth and female labor force participation has the significant relationship. So this one actually, based on the result, we can say that either there is unidirectorial or bidirectional causal relationship, and based on this, the policy makers or policy designers, they can implement a policy. Why? What is the reason behind that? And now, finally, we can estimate this is actually robustness of our model. So we can check this model is suitable for us or not. So this is actually the supportive for Airedale model. Why we use the Airedale model? And if this one, meaning that, so here, what is the strong justification here? If these coefficient values are similar with the long run Airedale model, meaning that same sign, not same value, but same sign and same significance, same level, not same significant, but significant. If this one, suppose this one, female labor force participation is positive and significance. You see, do you remember these things in our case? The long run relationship, male labor force participation was negative but significant, and female labor force participation was positive and significant, meaning that if our long run model of the Airedale model and this value is similar, then we can say that our model is robust. We can, this is actually supportive. We can support this model. Okay, now, okay. Now we need to, any question about this? Because we need to go to the second session.
Ma'am, I have a question.
Yes.
Since we are using the data of the article which you have mentioned, if we want to practice this, like since I have not written any empirical article and I want to practice and see the results, can you share the data set of this article which you were talking about?
Okay. Right now I don't have this data set, but I will give. Already you have got the data set, right?
Yes, ma'am.
Okay, I will show you that one. I will do it.
Okay, okay.
Okay, that one is the practical part. Okay.
Thank you.
Step by step. Okay. Any other question? Okay, so.
Yes, Dr. Rulia. Good
Yes.
afternoon.
Good afternoon.
Yeah, Linda here.
Okay,
Would it be possible to have access to your journal article? It's a very, very interesting paper, and me and my colleague are interested to read it. Would it be possible to have access to it?
Okay, I will try, but this one actually, this one I think restricted. So I will give you another article, same analysis. Is it okay?
Okay, thank you very much, Dr.
Okay,
Rulia.
welcome. Okay,
okay, we'll wait for that. Thanks.
Okay, thank you. Okay, so now we can continue to the Airedale analysis using EViews 12. Before using this practical part, I will show, okay, we can explain something here, then we can proceed. Okay, so here, today's article, actually, this is actually our title for this analysis, today's analysis, the effect of climate change on rice productivity in Malaysia. How the rice productivity actually affected by the climate change. So here, our dependent variables is rice production in metric ton, and we took cultivated area, rainfall, and temperature. So here, we didn't take only the climate change variable, but we also, this is non-climatic variable, right? So we also mention there because sometimes we need to add more variables. Otherwise, the regression analysis not fruitful. Sometimes actually we need to remove some variables. Sometimes we need to add more variables. If we have more variables, then if we need to remove, okay, easily we can remove. Suppose we have 2 or 3 variables, so we cannot remove. We can add, but we cannot remove. So here, actually cultivated area also related to the rice production, right? So that's why I put the cultivated area also. And here only I just mention the effects of climate change. So here independent variables, cultivated area in hectare, rainfall millimeter, temperature and Celsius. Okay, so here data period is 1982, 2019. So 40 years of the observation. This paper also I have already published this one. So this one I will, if you are interested, then I will show you this one later on, because that one actually difficult to download that one, but this one I think easily you can download it from the online. Okay, so here sources of data, I took all the variables as World Development Indicator and Malaysian Department of Statistics. So here, okay, so now I have this data, but I have here, do you remember that one? The descriptive statistics actually mean, maximum, minimum, standard deviation, and so on. So here, previously I have only gave you mean, median, and I think maximum, and standard deviation, total number of observation. Okay. If you want, you can put all the variable, all the that one is actually the central tendency, and this is the normality dispersion. So it's up to you. But sometimes the journal, they sometimes mention no need everything. We just pick up only some. Okay, so that's why I just put it here all. So here mean is the average value of the all the observation. So here researcher can easily understand or easily see how this value is. But one by one, actually it is very difficult. So our now the technology, right? The EViews gives us the result easily, make it easily. No need to put one by one. So here, standard deviation, okay. So I have already mentioned standard deviation, the measure of dispersion from the mean value. So here, if standard deviation is below the mean, I have already mentioned, so I just repeat, below the mean, meaning that this model perform well. And you see here the probability is Jarkabera. So Jarkabera is actually, we can see the normality test, either graphical or the here the table form. So if the p-value is more than this, more than the 5% level, meaning that the data is normally distributed. But here, one of our data is not normally distributed. But overall, in average, our model is normally distributed. We cannot consider only one value. We can consider all the variables because we have here 4 variables. So here, a null hypothesis is data is normally distributed and alternative is not normal. So here, if p-value is greater than 0.05, meaning that we do not reject the null hypothesis. So we can accept the null hypothesis is our data is normally distributed. You see here, total observation is 40 years. This is important. Sometimes we need more data than our better model. But you see, only 40 years. But if panel data, there is lot of observations, lot of data. So this is the flexibility of EViews model. We need a small sample size. Easily we can use the EViews model. Now here, I have already mentioned, this is repeated, right? But here, the correlation between two variables, okay, between -1 to +1. So here, 0 indicates there is no correlation, but cannot 0. 1 indicates perfect correlation. So here, actually, not like this, because rice production, okay, should be 1. This is the same. Okay, so now, how do we write up, or how do we explain this one? So you see here, cultivated area with rice production. Cultivated area with rice production has a strong correlation between the rice production. You see the value. Value is 0.828. And this is actually the, okay, I think this is not significant. So this is an weak correlation. I didn't put it here, the significance value, this one probability value I didn't mention. But once we do the practical part, we will do it. The temperature, also the rice production with the highly correlated. Okay, now you see here, the extent of the correlation between two variables increases. Okay, I have already mentioned 0 to -1. So this one, based on Densey and Reddy, they mentioned that if the variable or if the values are 0.1 to 0.3, meaning that there is a weak correlation, can be positive or can be negative. And here 0.4 to 0.6 is the moderate correlation. Okay, and there 0.7 to 0.9 is a strong correlation. So we can mention that this is the strong correlation. And why the strong correlation? Maybe we need to give the justification or support. So simply we cannot say that, okay, this is only weak relation. So why weak relation? Why strong relation? What is the reason behind? We must give the reason. Okay. Okay. Now, actually, you need to test stationarity. Okay, stationarity. Unit root test is the particularly used to check the stationarity of the time series data. Okay, so with the help of this test, we can detect, you see, whether the time series, the variables is stationary or non-stationary. How do we detect this? You see, this is actually if the data set or if the variable has trend. So trend meaning that this is the non-stationary time series data. And we have the trend, no trend. There is no trend of the variables, meaning that the variables are stationary. Okay, so here, why it is important actually for stationarity or determine the stationarity property? Is it important or not? Yes, it is very, very important. Why? Because before carrying any other regression, we need to do the unit root test. If the time series data is non-stationary and they have the trend, the result will be the spurious. And spurious result meaning that it doesn't make any sense, meaningless. So we cannot use the result. So that's why the stationarity test is very, very important. So here, unit root test actually estimated both at label and fast difference. Okay. Either intercept or trend, it's up to you. Okay, so here the null hypothesis, the variable is not stationary or non-stationary, whatever you say. Alternative, the variable is stationary. So if p-value is greater than the critical value, meaning that the variable is non-stationary. So if the variable p-value is less than critical value, meaning that the variable is stationary. So either 5%, 1% or 10% significance level. So now, how do we, if we have the value, you have the variables that is non-stationary, how do we do that stationary? I will show you the data. here you see the difference. You see the difference to same variable, rice production. This is also rice production. You see, this variable is the trend. You see here to here to here, go up and up. But you see, how do we, this is the non-stationary time series data. How do we make it stationary? One way is the differencing. So you see here, we just difference the data set. When the data set, we difference this one, you see, the very closer to the mean value, meaning that this one, you see the difference, the before difference and after difference, the data set is. So that's why you see, they're very closer here, here, very, very closer to the mean value, meaning that this is the stationarity and this is the non-stationary variable. So that one is one way to do the data set is stationary and detect from the unit. Okay, before going to hands-on approach, so maybe we can 5 minutes break or continue. Anybody, should we continue or just break for a few minutes?
Break for a few minutes, please.
Okay, okay, just 5 minutes, huh? Okay, thank you. I will come back after 5 minutes. Okay, thank you. Huh? Okay. So everybody is here?
Yes.
Okay, I got one question. Okay, so how small is the sample size? Okay, so thank you for this question. Okay, so actually the sample size is small, meaning that less than 80. So you can easily use the ARDL model. And another question is, in order to achieve reliability of the data analysis, actually we have the reliable data. So once you use the data analysis, this one reliable. Because how do you reliable? This is actually the time series data, because you need to do all the steps. Then because after that, once you analyze the bound test or error correction model, so this is actually the reliability, because here there is the sum of assumption. If you fulfill the assumption, meaning that your analysis is okay, right? And sometimes actually reliable data source is the problem, because we actually basically we use the World Bank's data. We think this is reliable data. So if this one not reliable, this is not our fault, right? Okay, now share. Okay. So everybody has the EViews software, right? Should I start? Should we start now? Response, please.
Yes, please.
Okay, okay, thank you.
Thank
If you are
you.
not
Yes,
response,
please.
meaning that you are not here.
Yes.
Thank you. Thank you.
Okay, so here I have already opened the EViews file. So now I need to import the data from Excel to EViews. So you have the data file, right? So how I can export? I just go to File, Import, go to Import, then import from the file. So here I have the data. Just you can choose the location. Where is your data? So I have data here, here. Okay, this is my data. Okay, so here, you see here, I have the data. So I just click next. You can keep it as it is. Next, next, then finish. You see this one, we can say no. Okay, you see here, how many observation here? I have 40 years of observation. So this is my data set, cultivated area, rice, this is rainfall, this is rice production, this is temperature, this is equals to the constant. So our dependent variable is rice production. I have already mentioned that one, because today I will show you, I didn't put lot of variables, because if I have lot of variables, sometimes actually problem of the analysis, and sometimes the problem we can make the table. Actually this was quite big, and also the data availability is the problem also. because sometimes it's difficult to get the data. Sometimes we need all the observation actually find out difficult. We feel some difficulties to get the data, and otherwise we need to buy the data sets. Okay, so here now I need to this. Okay, I will show you the data set. How? Okay, you can control. Then okay, rice production. You just click cultivated area, rainfall, temperature. Then right click with the mouse, open as a group. I think here I cannot see because of this. I think this okay. Sorry. Okay, I can do it again. Control, you just press the control, then cultivated area, rainfall, temperature. Okay, open as a group. Okay, so here you see our data set is there. So you see 1980 to 2019, 40 years of observation. So now I need to generate the log form of this data. Why I need to log form? Because you see some of the variables are too big, some of the data set are big, some of the small, so make it in the shape. So we need to generate the data series into log form. So how do we generate this one? Okay, if you want this data set, so I just name, okay, I just write data, then okay, and if you close it, so you see here we have data, so we can click here, then you can run it. So every time no need press the control or something. So here, okay, now how do we make the data is logarithm? So let's go together and then let's do it together. We can go to the generate, click here generate, and okay, first one is rice production. So LRP, rice production. L means represent a log. Okay, now you can put equal. Make sure the bracket, sorry, here you must write log, because this is the symbol, this is you must put in log form, and make sure the bracket and RP is our first variable or the dependent variable, then close the bracket. You see? Now enter or okay. So you see here, LRP, you see the variable already generated one variable. Okay, we can do it one by one, step by step. So all the variables we need to do it. Okay, now generate L CA, cultivated area, equal to log, then bracket. Make sure you must put the bracket. Now CA, sorry, CA. So close the bracket, then okay. Okay, so here, now generate LRF, this is rainfall, equal log of, okay, RF. Now enter. Then now temperature, generate LTM equal log of TM. Okay. So any question? Are you with me? Yes? Okay, rice production, cultivated area, rainfall, temperature. I just open as a group. Now this one I rename. This is okay. I just put okay. I just rename this one log data because this is our raw data and this is our log data. Okay. So any question or everybody is with me?
Yes, we follow.
Okay, okay. We can I can proceed, right? Okay,
Yes.
okay. Now I need to do the descriptive statistics first. How? You can go to the view You see, if I'm going first, that stop me. Is it okay for you? Okay, so here, go to the descriptive statistics. I just use the individual samples, common samples. So in samples, so here individual samples, you see here, I have all the information here. Mean value here, median, maximum, minimum, standard deviation, skewness, kurtosis, Jacobi, sum of square and total observation of 40. Okay, now how do you copy this one? You just Control A, select. Okay, then you just copy text and you can this one copy in the another place. So you can put in the Word file or something like that. Okay. So now I need to see the variable, this one, graphical form. How my data looks like. This is single graph. Single graph, if I put single graph, meaning that data set should be in the one figure, all data set together. But I just put multiple graphs. So line and symbol, I just put it. Okay. You see, my data set looks like this one. Okay. So here, same thing. You just Control A, then you just copy from the clipboard and just paste. Okay, now I can go to the view. Okay, okay, now we can see here, how do we test the correlation matrix and correlation? Okay, so here, go to view, covariance analysis, click here. We just covariance analysis and correlation, we click here. If you put this one, T statistics, probability, everything should be there. Okay, so here, everything is the same. We didn't touch anything. Okay, now I can press OK. So here, you see, this is the correlation matrix. Okay, so actually, if you have the data, it's actually very much fun for me. You can play with the data. You can do it several times. Which one you can change sometimes. Sometimes you can add more variables. Sometimes we delete some variables. Sometimes you put, you can use with log variables. You can without log variables. Everything you can do it. Actually, this is a lot of fun. Okay, so here now we need to do the unit to test or stationarity test. How do we do? Okay, you can go to the add-ins, because if you want, you can do it one by one. All the variables, because we have 4 variables, we can do it one by one. But if you have, sometimes you have 7, 8 or 10 variables, so it is tiring and time consuming, because we cannot use only one variable, and because I have, if suppose I have 10 variables, so I need to do the label, first difference, and either ADF test, PPS test, KPSS test, and whatever you want. So it's time consuming and tiring. So better we can do it at the same time all together. So how? Now you can go to add-ins. So here, if you don't have add-ins, this one, you just manage the add-ins or download add-ins. Because I have already this one, so you can go here, download add-ins. Okay, so here you can scroll down. Okay, so here, scroll down, all you need to test. Okay. Oh, sorry. Where is that? Okay. You can click here. URL. You can click here. URL. Then install it. Then that one automatic here, because I have already have the unit root test here, so I will not do it now. Okay, now I just close it because I have already. So go to add-ins. Now all unit root test, click all the unit root test. Okay, so here I need to enter all the variables. So our variable is rice production, then cultivated area, then rainfall and temperature. Okay, now you see here only one test. You want to test one. You see one single or all together. Okay, I can do it augmented decay floor and flip parameters together. So here Akhtar information or source criteria. So I just click here. I just change. If you want, don't need to change. It's up to you which one you choose. Okay, so here Akhtar information criteria. I just click OK. You see now. You see this is Philipron. Okay, I just go to the first augmented decay floor test. You see the first, okay, only rainfall has the significance at the level, meaning that stationary at the level. But after first difference, you see all the variables are stationary. So it's simple. But if you do manually, okay, I will show you the, should I show you the manually one by one, or this is okay? Okay, now you see here, this is our unit root test. This is Philip Barron. You see, rainfall, same as augmented decay flow. The at label, the variable is stationary. This is 1% significance level, but temperature is significant, but 10% level. So after first difference, you see here, what is the difference? After first difference, all the variables are significance, or all the variables are stationarity. Now, what should I do? Okay, so I can go it again. You see, if you want, you just Control A, just right click, copy text, then you can paste in your Word file. Okay, now go to add-ins again. All you need to, I can write all the variables name, rice production, cultivated area, rainfall, and temperature. Okay, so here I just want to test this one. Same as Akhtar information criteria, then click OK. You see? Okay. This is actually opposite of ADF and flip arrow test. This test, the at level should be significance. This one. But after first difference, actually, not significance. You see, the label, all three variables are significant, but this one not significance. As the different, opposite. But after first difference, this one significant. So you just put in a table form. If you want, you can use more test. For the ARDL, we need actually 2 is enough, but this is actually the common test. But another analysis like non-linear ARDL approach, we need to use another the test, another unit to test. Extractional break, we need to test that one, and also the FGLS stationary test. I have already used that one, but only the ERDL model we can use only this one. Okay, now, okay, I just close these things. Now I need to open dataset as a group. Okay, so here I need to select the leg or leg selection criteria. How? Go to quick estimate var. Okay, this is, you can here write all the variables, or you can write here one variable. So it depends of U, L, R, P. Okay, and I just put it here. What is the difference? I will show you the graph. What is the difference? Okay, first I just put it here. LCF, LRF, and TM. Okay, now I just put OK. Press OK. So now how? You see view. Now go to leg structure, and you see I will go to the leg selection criteria. Just click OK. You see here 3 legs include. So I just put it here because EViews select for us 3. So I just, okay, as it is. Okay. You see here. Which one is the lowest value? You see, if we focus this one, Akhtar information criteria. So the Akhtar information criteria, the leg 2 is select for our model. Why? Because this is the lowest value. If you want to use SWOT criteria, so at that time you can use leg 1. And if you use this one, so you can use also leg 2. So in this case, we can use leg 2. Okay, now again go to view, leg structure, and this one here, root graph. So you see the graph, the polynomial graph. So our all the dots are within the circle, meaning that we can use the appropriate leg 2 for our model, for our estimation. So, okay, now we can change this one. The problem, okay. I just put here dependent variable, and this is the constant. I just here put all the independent variable. So, what is the difference? I will check. Okay, so here, go to view again. Now go to leg structure, leg length criteria, 3 same. Okay. You see now, okay, we need to use 3 legs for this model because this Akhtar information, this is the lowest value of this model, and lowest value is the better model. So if you use SWOT criteria, so meaning that need to use leg 2. Okay, now I need to see the graph. What is the graph look like? Again, go to view, leg structure. Okay, graph. You see these 2 within the dot. Sorry, within the circle. So which one you want to choose? It's up to you. So this is actually some of the articles of some of the variables. Actually, we can see all the lot of dots here, meaning that they put all the variables up, or can be dependent variable, all can be dependent variable, or can be independent variable. So that's why that one. So it's up to you. And sometimes we ignore the graph also. Also the Lag selection criteria we also ignore, but we did it, but we cannot put it in our the research paper or article. Sometimes we just ignore, skip this part. Okay, now okay, I just close it. I just close. Yes, okay. Now this is our data set. So here, okay, I will show you if we do like this. Wait. Okay. Previously, I have shown you the add-ins method. All times, all the variables together, then all the unit roots comes together. So if you want, you will do the manually. So how? You just go to the quick here, series statistics, go to the unit root test. So here, which variable we need to check? I can check here, rice production. So you can put it here, okay? So here, first you see how many tests here? Augmented decupolar, decupolar GLS, Philipparum. So here, lot of tests. So you can choose which one you want to use. Okay, augmented decupolar. First, we need to check at label intercept. So I put it, okay. You see, this one is not significance, meaning that, so these are not stationarity at label. So how do we do it? Okay, so here, go to, okay. Okay, then I just click here first difference. I need to save what is the difference if after first difference the variable is stationary or not. So now click OK. You see, now p-value is very lower, right? So meaning that the variable is stationary after first difference. So actually this is time consuming. You need to do all the variables like twice for one test. Meaning that if I have 4 variables, so I need to do this augmented decupolar, so 8 times. And if I have another more test, so it will take longer time. That's why I just use the add-ins method. Okay, now I just close this one. Okay, now I need to do the bound test. There is the any long run relationship exist or not. I want to check. Okay, so how? Go here, from, then make equation. Okay. So here, you see here, the EViews automatically say here, have written our variables and constants. So if I made I will do it the make equation. So meaning that we need to write the equation manually. It is actually difficult for analysis because sometimes if we have 10 variables, we need to write all the equations. And if one, sometimes if you did wrong, one bracket, something like that, then the result will not comes out. So that's why I just use this one, whatever the EViews said. I just go here, click here. This is our ARDL method. I just go here. Auto-regressive distributed lag model. I just click here. Okay. This is the question here. Because you see here option, Eka information criteria, okay, specification. So if you put here, I just put constant because the EViews select for us the 4 maximum lag. So I just see what happened here. Just click here, okay? You see, this is the dependent variable method ARDL. Okay, so maximum dependent legs is 4. This is automatic selection. Okay, now model selection method is Akhtar, already mentioned. Okay, dynamic regressor 4 legs, automatic, because we didn't change anything. Okay, now this is actually the constant number of models. Okay, evaluated 500. Okay, selected models. Okay, you see here 1310. What does it mean? Okay, meaning that you see here one leg for our dependent variable. You see here one for our dependent variable leg and 3 for our next independent variable leg, because our independent variable is cultivated area. First independent variable, you see 3 legs, 1, 2, 3. Now 1 text variable is rainfall. Rainfall has 1 leg, you see here. And temperature, this is 0, meaning that next variable has 0 leg. You see, there is no leg values. This is actually, this is, what does it mean? I will explain again. I can explain now again. So 1 for dependent variables, 1 period of lag for dependent variables, 3 legs for first independent variables, and 1 leg for second independent variables, and third legs, this one is for third variable. So 0 meaning that there is no lag values. You see here, our adjusted R square is okay, quite good, 93%. And F statistic probability is, this is significant probability is you see 0.000, and you see Darwin-Watson value, it's 2, more than 2. Okay, so here you see here, you can see the rice production can influence itself. You see here significant value, but we can check with the world test. With the world test, we can check also. Here, this one is actually C1, C2, C3, C4, C5, C6, C7, C8. So here, cultivated area, you see, but cultivated area has jointly significant or not. We can check through the wall test. I'll show you, because here 2 variables are significant. Oh, sorry, 2 legs. You see, this is no leg. This is leg 1 period leg. It's significant, but these 2 is not significant. But I can check whether this is jointly significant or not. There is the okay. So here C2, C3, C4, C5. Right? C2, 3, 4, 5. So how? Go to view, coefficient diagnostics, wall test coefficients. Okay, so here you see C bracket 2 equal C3 equal C4 equal C5 equal 0. Okay, you see? So you can check one by one, and you can say that the cultivated area is jointly significant, or cultivated area have significant influence on rice production. Okay, now I can go back. Okay, now actually I want to see the bound test value. What is the bound test value here? Go to view, coefficient diagnostics, go here, long run and bound test. You see here. Okay, you see This one cultivated area rainfall significance, but what is the problem here? But our AP statistics is not greater than upper bound critical value, right? So here you see here, not 5%, not 1%, not 10%. So we cannot use the ideal model, right? So now we can make some tricks. So how? Estimate. Okay, so here, okay, I just do it here. Just check one by one because we need to here I just check here restriction and trend. If this one, if our model that one is a bound is more than critical value, then okay, we can continue, or not we can change the leg. Okay, so here, okay, go to the view again, coefficient diagnostic test. Okay, long run bound test. Okay, what is our bound test? Okay, now you see here our bound test value is now 6, right? So our 1% significance level is 5.23 and 5% 4.23, 10% 3.74. So we can conclude here our AP statistics is greater than 1%. You see upper bound critical value of 1% level of significance, meaning that there is a long run relationship exists. So, and you see here also the significance level here, because there is the rainfall, there is a significance, but 10% level of significance. But you see here 1% level of significance. This is 5% and this is also 1% level of significance, meaning that more influencing of the rice production. So here you can see, because if you have data, so you just play with the data. It's very fun, very much fun. You can enjoy. Okay, now we can see the error correction tab. Okay, so how we can go to the view, same as before, then coefficient diagnostics and error correction form. Click here. Now I can check. Do you remember the criteria? Yes, you see here. The error correction term, this one should be negative and significance. If negative and significance, meaning that there is a long run relationship exists, and this one back to the from the short run to long run. So how many percent is speed of adjustment? So you see here the critical value, sorry, the error correction term value is 86%. So 863, meaning that 86% speed of adjustment. Now the question, if we can find out the year, because this is the yearly data, how do we find out that? How many years need to get the reach the equilibrium point from short run to long run? How many years need to adjust? So how do we find out the value? Okay, just 1 minute. Okay, so here you have the calculator, so you can you can find out 1 over 0.8. No, sorry. 0.863. So I have the value 1.15, meaning that 1 year or almost 1.5 years, or you can say only 1 year. We need to reach the equilibrium point. Go back to the equilibrium further from the short run to long run. Reach the equilibrium point. So speed of adjustment is 86%, or we can say if we convert it yearly, then it is it will take time only 1 year or 1 point. You mentioned this one 1.16 or something like that. Yes. So far, okay? Okay. So until now, okay. Do you practice with me? Yes?
Yes, we follow.
Okay. That's good. Okay, so here, actually here, same as before, if you want to check you see here, the cultivated area is jointly significant or not, you can see here, from here and here. Because sometimes we need to check through the word test. So we need to check like as before, I just have already mentioned. So now we need to check the diagnostic test, right? Some diagnostic test. So what are that tests are? So some diagnostic tests actually we can use the free from serial correlation or free from heteroscedasticity, normality. So how do we check it? Okay. Okay, so now we can go from here, go to view. So here, residual diagnostics. Now, serial correlation LM test. This one include legs, automatic selection. Okay. Let's say okay. Okay, if you see no serial correlation at up to 2 lakhs. So here, if the observed R square or chi-square value is less than 0.05, meaning that there is the correlation exists. So if correlation exists, we cannot take this model. We cannot proceed. So we need to go back to our main equation. So we need to add more variables, or we need to add lag variables, or we need to strong justification why we need to put this, or you need to go to the theoretical background or the previous research. So in this case, our model has free from correlation. So if free from correlation, so next step, we can go to view. Okay, sorry. Residual diagnostic heteroscedasticity test. Okay, so here we can use the Borus-Pagan heteroscedasticity test. So you see the equation, it look like this. So it's difficult to write manually, right? So here, if we write, sometimes you see here, the bracket and negative, lag 4. So it's difficult to write. So better EViews write for us. Now, okay. You see here, this one also the same. So meaning that our model is free from heteroscedasticity problem. So our model is beta model. So now again we go to view. Now we check the normality. Is our model is normal? Data set normal or model normal? So how do we do it? Same as go to residual diagnostics. Okay. Before going to that, we need to heteroscedasticity artifact, because sometimes we can check it. You see, this one also no earth effect anymore here. Then meaning that our model does not have any problem, any issues about that. Now go to view again. Okay, now histogram normality test. Okay, now you see here, click the variable. Okay, how? Okay, so here normality meaning that the data distribution is normal, and the null hypothesis is distribution is normal. If alternative is distribution is not normal. But if p-value is less than 0.05, so we need to reset the null hypothesis. So our probability value is more than 5%, right? So we cannot reject the null hypothesis. Null hypothesis is the distribution is normal, meaning that normally distributed. So here we accept null, right? We cannot reject null. So our distribution is normal. So once you just put the value only this one, Jarbera and the probability value. So we can check only this value. Now stability test. Our model is stable or not. How? Go to view again. Now stability diagnostics here, recursive estimates. We can click here. Now we can see here Kusum test. Click Kusum test here. And okay. Now you see here. Our value is this one, this line, the blue line is within the two red dotted lines. So here, red dotted actually the 5% significance level, meaning that our model is stable. Stability of the middle. To check the stability, we use Kusum and Kusum square test. So here, if our this line exceed this line, these two lines, meaning that the model is not stable. So something is wrong here. But our model is so far so good still until now. Okay, now we can check. Okay, so here stability diagnostic Kusum square. Click OK. You see here? Wow, so far so good. Nice. So here, this one also, the line is within the boundary of 5% significance level. So here, we can say that our model is stable because our both tests, Kusum and Kusum square test, is within the 5% level of significance. So our model is stable. Now we need to check the causal relationship, right? What are the links? Is there unidirectional causal relationship or bidirectional causal relationship? We can check. So how do we check that? Okay, I'll go to, I just click here because I have a lot of things here. Excuse me. Okay, so we need to go to quick here. Click here, quick. Okay, same as before, I just put it here. The variables, what are our variables? Rice production, then cultivated area, then rainfall and temperature. Then okay, I just put it okay, view. lag structure, you see here. Granger causality test. Here you can use this test, Granger causality test. You see this test, dependent variables. Okay. Okay. So here or okay, blocks in exogeneity wall test here. So here you see here only temperature has the significance influence on rice production here. Only one way. But overall, there is a significant but 10% level of significance. But here, temperature, but overall, no significance with that. Because you see here, if the dependent variable is rice production, if there is a dependent variable, the last time I have mentioned, if dependent variable should be more. Okay. And this one also, there is no significance result, but here, if the temperature is the dependent variable, there is a significance result here. But I can check here. Okay. I just go back here. What is the difference? Copy, paste, view. Okay. You see, now is the better result, right? You see this one, but this one is not significant at all. This one also not. Okay, this one cannot take it. So better we can use that one. Okay, so here you, okay, if we do this one, okay, estimate. Okay, I just close it. Yes, okay, now if I show here, same thing here. Sorry. So here, okay, you see here. Now if we see the causality test, I can go to quick, then group statistics, then Granger causality test. I said put it okay. That is the 2 lakhs automatic selection. I just press okay. Yes, group. Okay, now you can see this one. You can see here cultivated area, rice production, cultivated area, there is no significant result. But here, you see here, temperature and rice production is significant. Okay. So here, they have both direction. Temperature has influenced the rice production, and also the rice production has influenced the, you see here, both the significance results, meaning that here is the bidirectional results, right? So here, okay, so if you see here, cultivated area and temperature, also significant results, but one way causal relationship. So here, rainfall and temperature also one way, but if you, now we can check, if we change the lag, what happened? Is there any change or not? View, sorry, just, okay, quick. Group statistics, causality test. Okay, I just check here 3 lakhs. Then I can check actually, because you see 3 lakhs, we see once 2 lakh, meaning that 2 lakhs that one gone. So our observation was 40, right? Now is 38. Okay, now you see this one is 37 because I have included one more lakh. Okay, so here same thing. Same thing here. So you just, but here there is cultivated area and rice production. There is here causality. There is no causal link here. But here rainfall and temperature as the causal link. But here temperature and rice production. Rice production also here. Rice production and temperature should be linked, right? Because if rice production or the temperature increase, meaning that the production should be decreased, sometimes increase, depend on the actually crops, right? Because some crops need more temperature, some crops need less temperature. And sometimes if the rainfall, if more rainfall, so meaning that heavy rainfall, this is causes the flood, and that one affects the production. Okay. And now, okay, I'll just close. Okay. Okay, open as group, same as this. Okay, now go to, okay, make equation. Okay, now I want to see the what called robustness of the model. So here, how do we check? Okay, I just check here. Point regression. Go to the point regression. So I have already mentioned we can use either fully modified OLS or you see here dynamic OLS or canonical co-integration regression. You can use one and compare with your long-run ARDL model, or you can use both, or you can use three. But sometimes actually all models are not similar with the long-run ARDL model. That's why or whatever which model is fit for us, so we can take this 2 or 3. So I will show you both 3 models we can check. Okay. Now, firstly, we can see the fully modified OLS. So here I will not change anything. See our, okay, here specification option. This is actually the OLS. So here I just nothing. I will not change anything. Just click OK. Okay, you see here. Okay, so do you remember the long-run equation model? So the cultivated area was significant, right? And this is similar with that. And rainfall, because once we check the trend and constant, that time our model was better. Am I right? Okay, so here you see these 3 variables are the positively related with the dependent variable, positively related with our rice production. So here, as we mentioned here, you see here, probability value is this one is 1%, this one, this 2 is 5% level of significance. So this fully modified, you see here, the dependent variable is rice production. Method fully modified least square. So you see here, all the variables are similar sign and significance level with the ARDL, long-run ARDL model. So you just explain like this. Once you put in a table form, we just mention that fully modified least square model we used for the robustness to check the robustness of our model. So based on the result, we have the similar conclusion because the ARDL model, a long-run ARDL model with similar our FMOLS findings. Okay, now go to estimate again. You see here, now dynamic OLS model. Click here, okay. Now, okay. You see, but you see, cultivated area is not the same, right? But here rainfall and temperature. So you can, if you want, take this one. So you can say except cultivated area, other two variables are similar with our long run ARDL model. If you want, you can say like that. If you not, then you can skip this part. Now, last one is estimate. Okay. Now, last one. So here, now we can click OK. Then you see here, this one and the DLS is the same result, similar results. Okay, so here you can mention as before as same this one. So once we compare, better we can compare with which model is actually which this one is the method conjugation, canonical conjugation regression. So here you can use which analysis is similar to your the ARDL long run ARDL method. So this is the way you can check actually. I think, okay. So here, okay, this one minute. Okay. So here, now, when we check the ARDL model or any other test, we can actually, once we only write the equation or write the justification, then and you must put the strong justification. Sometimes, suppose we have the rice production and okay, here cultivated area. For example, this is if we have this is the our long run model. For example, this is not actually the long run model, but just guess. Okay, so here cultivated area and the rice production should be positive and significant, right? Because if cultivated area increase, meaning that you can product more, production will be increased. So here, why? Because the assumption, so hypothesis, if the hypothesis does not support, so what is the reason behind why this hypothesis is not supported? You can see other the previous results, go back to the previous results, or if you don't have the strong justification, maybe we can include more variables. Then after that, you can again rerun another. Maybe we have the omitted variables, meaning that some important variables we just ignore. We omit that variable. So we need to add more variables and we need to go through the theory. We can make sure we need to understand the theory and also the previous research. Based on the literature, we need to search more literature. Sometimes the weather condition also the effect, right? So here, rainfall. Rainfall has significant influence on rice production. Sometimes it's true, right? Sometimes if your hypothesis should be if rice production has a significant and positive influence on rice production, okay, so far, okay. If you think your hypothesis is negative, then why you get positive results? What are the reason behind? You need to find out this. This is actually the research. You need to find out and you can give the strong justification. Okay, two or more, 2, 3 more, you can justification. So if you give the more justification, meaning that you have the strong point. So you can easily argue, yes, I got this one, but previous studies, they also get the same result. So what happened? What is the problem in mine? Because this is justified of the based on the previous research. Okay, so far I think we are in the last stage, so I have already done. So far, any question about the analysis? because next time we will do it the NARDL analysis if you are interested, because this is for the beginners. So in non-linear ARDL actually for the advanced level. So we will do it inshallah next time if you are interested for this. Okay, so far any question for this? Any question? Yes? Everybody is with me? Any question? I didn't hear from you.
So far, so good, doctor.
Okay.
Thank
Okay.
you.
So, okay, I just give you one important thing. Actually, you know, how do you difference the data? Okay, I will show you, because this one actually, if you need, sometimes we need the data, because I have already shown you how do you generate the log form. So now that one is actually sometimes we need. So I just, okay, so here, how do we difference the data set? Because you see here, this is our cultivated area, suppose this one. So once we difference the data set, how the data set looks like, I will show you. So here, you just go to generate. Okay, so here, you just write D and which variable you want. Okay, so here, I just put L R P, rice production. So you can equal bracket, sorry, here you just write D bracket, same as the log form, but here the difference, that's why we put D. D indicates the difference. LRP, rice production. So here enter. So now I will show you the data. This one, right? Okay, you see our data is totally sense now. You see, if you this data, now if you do the graphical change, you see here, view, graph, you see your data, you see, this one is the stationarity, because you can check also the graphical format, because you see the 0 meaning that mean value, so this one is white, is that you see the close to the mean. But if you see here, rice production, you see the data, you see this is the trend. So that's why sometimes we need the data, we need the difference. So once you do it, actually you can see from here, this variable or this data set is stationarity criteria or not. They fulfill their criteria or not. You can see from the data set also, from the figure. So for any question? Any question? Is it clear for you, participant? Yes? Is it clear?
Yes, it's clear.
Okay, so any question?
Ma'am, I was unable to follow few steps.
Okay, which step you didn't follow? Just
No, I was able to understand everything,
okay.
but since I'm doing it for the first time, so especially about VAR model, which we're trying to tell. So I was asking, What all tabulations do we need to mention in the article?
Which
Because
one?
what all tables which we need to mention in the manuscript or the article? Since we have done a lot of
Okay, I get it. Okay, so here actually, once you will test the Airedale model only, so first you need to do the descriptive statistics, because overall this is the overall figure researchers or the reader can easily understand. Then you skip the correlation matrix, it doesn't matter. And secondly, you need to do the unit to test. And sometimes we after descriptive statistics, actually we can, okay, just 1 minute. I just show you one article if I have. I just
Okay.
check, just okay, because I think because analysis actually very simple, but we need to concentrate more. This article. Find now. Okay. Okay, so here. Okay. This one. Okay. Can you see this file?
Yes, ma'am.
Article. Okay. So this is one of my article. This one also published. Okay. So what is that? Why this one comes? Okay. Here. Okay, so here in this article, because the data set I just use here. You see here, in this article I have focused both symmetric and asymmetric, meaning that linear and non-linear, because sometimes actually difficult for publication. Okay, so here you see here, I just put it here. For the Airedale, you see here, same variable. I just focus on rice production, cultivated area, rainfall, temperature. Then you can just, this is the method, nonlinear, okay. Okay, descriptive statistics, you see, I just put it here only. Mean, maximum, median, minimum, standard deviation, and observations only. No need all the things. Okay, so and make sure once you write a manuscript or your thesis, you just after the point you just put 3 decimal points, not all. Okay, so here sometimes you see we put it the figure here. So if you want to skip, no problem, because sometimes the journal asks the limit. They have some limit of the word. So if we put a lot of figure, lot of graphs, it's then exceed the limit. So they are not actually accept the paper. Okay, so here you see that unit root test, you must put it there. So if 2 is enough for the paper, because here I have used 2 methods. Either that one is both Airedale and non-linear Airedale. That's why I put lots of the You see that you need to test lot of tests. So here, okay, this one is structural break, this one for nonlinearity or NRDL. So no need this one. So you just, okay, co-integration, you see the lag selection criteria. I just put it here. Sometimes if your manuscript is too big, so you can skip also this one. So you just write in a word. We just select this lag in this model. So based on this criteria, whatever you use this criteria. Okay, now you see the polynomial graph. So this one also you can skip. If okay, so this is important. The bound test result. You must put it there. And also this one, the after that long run, you see here, you see this is the ARDL model. So if you want, you can make one table. Previously, I have shown the same table. We can use the short run and long run. So here I just put it separately. So if you want, you can make sure you just put it here. One left side is long run and right hand side the short run. And in the same table, you can put the diagnostics. No need to put the another table. Meaning that if you put another table, that one is also countable. So better you can put in one table, single table. Okay, diagnostic test we need. After that, okay, this is actually non-linear, no need. Okay, so this one we need. The stability. We must need the stability. Okay, and if and this is okay, stability. You see here, robustness of the model, analysis, causality. You see here, I have mentioned here all, but if you don't have enough space or so better you can use the causality also. Causality, then no need robustness. If you want, you just skip it, or if you want, you can keep it. It's up to you. You see, this is for non-linearity. This is not for this. You see the causality test. And the, you see here, I put it all three methods together. And okay, so I will see here some, okay. Any question? Thank you. Any question?
No, ma'am. Thank you, ma'am.
Okay. So if you are interested, then we will do it another workshop for non-linear ARDL model, because this is for the very beginners. So actually we will do it later on.
Ma'am, one very simple question.
Okay.
The data set which you have shared is for Malaysia.
Yes.
If we want to try for a panel of country, suppose BRICS or SAARC nations, do we have to follow the same steps, or
yes.
the procedure will change?
No, actually, the panel estimation is the different.
Okay.
Because some of the estimation are same, but panel have some additional criteria.
Okay, okay.
But some of the steps are same, but some of
Okay.
the steps are quite not similar.
Okay. And when do we have NARDL workshop?
Okay, you will be in the you have the email address or something like that. So we can, once we will announce. I think November, I don't know yet, but hopefully end of this year, because we have only 2 months, right?
Okay, ma'am.
So we will do the non-linear ARDL also, because non-linear ARDL actually the advanced level, right?
Okay, thank you, ma'am.
Any other question? Anybody? Okay. Any question? Any question? I think.
You're doing good, Dr. Rulia. It's okay.
Thank you.
Thank you very much.
You are most welcome. This is actually our first workshop, so next we will conduct with the nonlinear ideal method also, and after that I think we will do also the not EViews software, I think Stata, and also the panel data.
Okay, thank you.
One
Please,
by one.
yeah, please keep us in the loop so that we can as well participate the next round.
Okay, sure. Thank you.
Thank
Thank
you.
you. Thank you.
Welcome.
Have a nice weekend to you, Dr. Rulia.
Thank you.
Thank you. Bye-bye.
Okay, bye. So if no question, because we have still time, so if no question, then we can wrap up. Or anything, you just include if you have my number, the email, then you can just email to me. We can communicate with email. Any question? No. So far, okay.
Yes, ma'am. Ma'am, like if I start applying the steps which you have mentioned, in case I face some problems, should I reach out to you in the email?
Yes, sure. No problem.
Okay, ma'am.
Dr. Rulia, is it
Yes.
possible for us to get the recording so that we can repeat to listen it?
Okay, I will ask to the center first because they have I think a recording, and I think they can give to you if
Thank you
possible.
so much. Thank you so much. We would like to refer back again,
Okay.
especially some steps of the EViews because
Okay,
I'm not.
listen, if you we have still time, so
Okay.
maybe if you want, then I can go through the step again, just shortly. Which step you need to focus on?
Because I'm not familiar. Actually, I'm not
Okay,
familiar with
familiar.
EViews.
Okay.
Can we do this model by using the SPSS? Do you think, Dr. Rulia?
I think spaces, no. I think starter can.
Oh, Stata can. Okay. Because I'm not.
Starter
Okay.
or R can.
Oh, okay. Thank you.
But for my understanding, SPSS cannot. SPSS actually, basically, I think the primary data, right?
Yes.
But this is actually the secondary data.
Oh,
This is,
okay.
This is difficult to do the SPSS subject.
Okay, thank you.
Welcome. So now, if no question, maybe we can wrap up. If you have question, then just let me know. Then I can try to solve the question, or any step you skip, or you didn't focus. That one I can go through because I just went through very smoothly, not too fast, right? So if So far, no question, right? If no question, then thank you very much for joining this workshop. If this one helpful for you, then I'll be happy, because actually, if sharing, this is actually sharing knowledge. If my small knowledge, if you have get benefited from something from here, I'll be happy. And if you have any problem, any question, you just let me know. I will try to solve the problem. And you can contact with my email address, I think, or you can go through the center, then we can, or whatever, you just give to me your number, then I can contact if you have any problem or anything. So any question, anybody?
Is there any WhatsApp group, ma'am,
Where
we can ask our doubts? Or
no WhatsApp group, because actually this is our first workshop, so that's why we didn't create a group. So any question? No? So no question? Then we can close the session.
Sure, doctor.
If you don't have any question, so maybe we should close the session.
Yeah.
And next time we can do it again together.
Yes.
Okay.
Yeah.
Okay. See you.
See you in future, doctor. Thank you.
Okay. Thank you.
Thank you.
thank you, ma'am.
Welcome.
Okay, bye.
Bye. Thank you.